Well, g'day everyone. I'm a bit tongue-tied today. In fact, I'm just a bit tired. Okay, well, welcome everyone. Welcome to Toolbox Tech Talk. Let me just fade that music right out. And so today we're going to be talking all about 5139. Now, I can just see I'm getting a bit of echo coming in here. Hang on a second. We're going to be talking all about 5139. Now, I can just see I'm getting a bit of echo coming in here. Hang on a second. We're going to be talking all... Yeah, okay, so I've sorted that one out. Just too many windows open, everyone. Almost every time I do this, I discover some new little trick to get it all working smoothly. But yeah, so welcome to Toolbox Tech Talk here at the Smart Energy Lab. Gee, I said I'm a bit tired. I've been out in the sun, yay. Been working on our micro solar farm. We're building a small solar farm here. In fact, it's a demo site for a solar farm company, Architect Solar, in partnership with Longi Solar and my company SolarQuip. So we're building a demonstration site of their single axis trackers, and gee, it's a lot of fun. We're doing the engineering as well as the electricals, so putting in posts and poles to millimeter accuracy. So it's quite demanding because you've got this 90-meter long shaft basically that rotates from morning to night, tracking the sun, and has to be spot on in terms of straight and level, and no twists and bends. So yeah, just been doing that all day with my team here at the lab, and yeah, so I'm going to do a little video on that once we've finished it and got it up and running. So I'll do a Toolbox Tech Talk, probably several actually, on tracking systems. Just a shout out to all those people coming in on my live at the moment. I can see people in YouTube, thank you, on the Smart Energy Lab YouTube channel, and I can see on my Smart Energy Lab Facebook page. Always have a few supporters there, and also the solar and storage trainers. LinkedIn's my new one from a couple of weeks ago. I started streaming to LinkedIn, so that's another place you can catch me. But yep, feel free to ask questions, and I'll drop in on the Q&A and check it out as we go. So first up, I just want to say that today's all about where can you install a battery system, considering the battery standard, AS/NZS 5139. Now that battery standard was published last year, I think it was October last year, came into force in all states and territories in Australia middle of this year. It's under a kind of quasi-compliance in New Zealand as a sort of best practice guide, though not referenced to New Zealand electricity regulations. But irrespective of all that, it does have a big impact on where you can install a battery in a domestic installation. So domestic is where the risk factor is deemed to be high, and it's got quite a lot of restricted locations. So we're going to be looking at those today. To make it a bit real, what I thought I'd do is, as I've done on a few of my previous Toolbox Tech Talks, is do a bit of a walkabout with a camera before my live show this morning, and just film some systems around the lab. Now, I live on an off-grid community, so there's a lot of houses here with solar and battery systems, and so some of those, in fact, I might just bring up a picture of it for you. Let's have a look, see if I can bring that up. Here we go. So that's Murumura Co-op, where I live. That's only a part of it. It's quite big. There's 70 people live here. There's 30 homes, and my home's right in the middle there. The sun's actually just hitting the second story in that photo. It's also where my Smart Energy Lab is, where I do my testing and training on smart energy products, particularly solar inverters, battery inverters, solar panels, smart energy management and monitoring systems, solar hot water systems. We've got some innovative technologies as well, like creating fresh water from sunshine and air systems, you name it. We also have a microgrid. So what you're looking at there, those homes are all connected together. There's about 7 homes on that microgrid, and they're all connected together through a low voltage network, and there's a 3-phase system at the lab that forms that network. Now, I've shown that on previous Facebook and Toolbox Tech Talk, so I won't do that again. But I will take you on a little walk and talk around some of the houses that you can see here this morning to talk about where you could put a battery system. Almost all of these systems were installed before 5139. Only one of them has been installed since, so it's a little bit, it's compliant, so I should say. So that's an important differentiation. Just a reminder, everyone, if you're joining me on one of those channels that you can like me and subscribe, like YouTube or Facebook, please do that. That's always really encouraging to get a few likes and a few more subscribers. Also, I run training courses. I mention this each time I run my live sessions. I run training courses in solar and battery design. Also, I'm doing some courses for electrical inspectors at the moment. I'm doing one this coming week. It's a 3-day course, but it's only 4 hours each day in the morning. It's designed to be sympathetic to New Zealand electrical inspectors, so it starts at 7:30 a.m. New Zealand time, which is 5:30 a.m. Melbourne time. I'd hate to think what it is in WA, but I will be running some at a more reasonable hour for Australian electrical inspectors. So I'll be covering the 3 main standards in that course, the battery standard 5139, the PV array standard 5033, and the inverter standard 4777, and bringing an awareness around compliance to those standards. Incidentally, I sit on the standards committee, so I've got a fairly good working knowledge of the standards. But ultimately, those who are responsible for enforcing them are responsible for ensuring that they have appropriate training and can comply with them. So I'm just providing best practice professional development, really, for electrical inspectors, and also for my courses, which are aimed at installers and designers, and even the general public who are interested in renewables. That's my 5-day course. Now, that'll be, it's not actually listed yet, but it'll be coming up soon. I should just bring myself back on screen, by the way. Here we go. Oop, there we go. That'll be listed soon on my solarquip.com website. You can go to solarquip.com and check out what courses are available there. So I should be running another 5-day course in probably about 3 weeks' time. Great. All right. Well, let's get into it. That's enough self-promotion and other talk. What I wanted to focus on today is the battery standard, and therefore I'm going to take you on a little tour first of some systems around the Smart Energy Lab. And by doing that, you can get an idea of how the standard could be applied, and then we'll look at the theory, and then we'll review some of those installations if we have time. So let me just see if I can bring that up on my screen. So I'm just going to start a little video and play that to you. So let's have a look, see if that's going to play. There we go. Okay, that's going to play. All right, so first up, this is actually my house, and at the back of my house, that's the south side, is a Alpha ESS Smile 5 system. It's quite a tall house, so you can see it's 2 stories. One of the requirements is that there is no equipment within a zone. So 600 mils horizontally and 900 millimeters above, that's not associated with the installation. So if we look at this system, which was installed long before 5139 came into force, I'll just pause it at this point here. This system it wouldn't comply these days for a couple of reasons. First one is that because it's on a residential installation, there is habitable rooms associated with this structure. On the other side of that wall is a bathroom. So it's deemed to be a habitable room according to the National Construction Code. So that's a problem, because then I need a fire barrier that extends 900 millimeters above and 600 millimeters horizontally from that battery system. So a sheet of form ply, which isn't nearly that big, it would not do the job. The materials listed in the standard include concrete blocks, cement wall, a brick wall, terracotta surface, or compressed cement sheeting, and or any of its fire-rated material to AS 5139. So, sorry, to 1530.1, which is a fire rating or non-combustibility standard, AS 1530.1. So let's just move along a little bit from this one and have a little look down the wall here. So the other issue is you can't put a system underneath a window. So you can see there's a window there. I couldn't put a system underneath it, and I have to be it can't be underneath or within 600 mils of the window that ventilates to a habitable room. So that's once again a bathroom with a sliding window. So the sliding side of the window is effectively off limits by 600 mils horizontally and not below. So can't really put a battery system there. Incidentally, I reckon I could install that Alpha ESS in a compliant manner if I shuffled it over a little bit more towards the corner and put a fire barrier behind it. That's a straw bale house, by the way, so it's not one of the fire-rated materials. And no Three Little Pigs jokes, please. So let's have a look elsewhere. Now I'm going to go over to my neighbour's house and have a look at my neighbour's house in a minute, where we have recently installed a compliant system and looked at some of the issues that we had to solve to meet compliance to AS/NZS 5139. So there you go. That's a fixed window. So actually you can be within 600 mils of that window because it's fixed and it doesn't ventilate to a habitable room. But if it was a ventilated room, then I'd have to stay further away from it. But I'd still need a fire barrier because this wall is not fire rated and it is a habitable room behind. So here we go. This is my neighbour's house. There's a nurse and a builder who live here, so there's a bit of equipment sitting around outside, a few extension cords. This is the eStore. It's a BESS, a battery energy storage system. We'll talk more about what a BESS is in a bit. And you'll note that up the top there is a inverter. That's another solar inverter. There's actually a solar inverter built into that BESS inside that white case, the eStore. But there's an additional piece of equipment which is a SolarEdge existing solar inverter that was already at this installation. Now there is some lack of clarity in the standard about what is deemed to be associated equipment. Is a solar inverter associated with this BESS or not? And if it's deemed to be not by a regulator, it has to be more than 600 mils horizontally and 900 mils above. There's an exclusion zone of that size around the battery energy storage system. So if that was deemed not to be associated equipment, and you're probably wondering, Glenn, can't you just tell me? Well, I can't because the standard's a bit opaque about that. There will probably be a ruling in Australia from ERAC on what's deemed to be associated equipment. I'm not sure if that's been made yet. So we're still waiting to see what clarification comes from that. So just moving down a bit, the wall behind there, or the original wall, if I pause it again, you probably can see is a weatherboard, so definitely not a fire-rated material, and also straw bale, not a fire-rated material. So we had to put up some cement sheeting that extended 600 mils horizontally at least and 900 mils above, but because the eave was less than 900 mils, we had to line the eaves. So you can see there's some eave lining has been done as well with cement sheeting. If the floor was combustible, which it's not, it's brick, it's okay. But if it was combustible like timber, it would have to extend 600 in front and 600 to the side, a non-combustible material. Now, there's a gas bottle system there that definitely would be not allowed within 600 mils horizontally. That's not allowed just because of AS3000 as well. And the other question that sometimes comes up is, do we need a bollards, or do we need a barrier from impact from vehicles? Now, it's not actually written in this standard. It says nothing about barriers for vehicle impact to battery systems. It really is the principles of AS/NZS 3000, which is our wiring rules, that you need to have adequate mechanical protection for electrical installation. And if there is a potential impact from a vehicle, because it's in a garage, or in this case, it's a driveway which the car parks right at that point where that barrier is, there is a potential of impact with that electrical installation, the battery system. So those posts are, concreted into the ground, the hardwood, so that's the barrier. People are often using bollards, which are pre-made. Some anchors can be drilled into the concrete, for instance, as a protection system as well. So that's something you need to consider. Is there a likely impact from a vehicle or other, and do you need to have protection from that? So moving on here, we're going to look at a tiny house. So this is a tiny house on the property, and it's on wheels, but basically it's not going anywhere fast. It's got a solar system, which you'll see in a little bit on the other side of the north side of the building. On the south side, there is a battery system. Now, this was installed about 5 years ago, long before that battery standard came into place. And that tiny house is made of weatherboard, and so you would consider that to be a non-fire rated material and require a barrier to protect against the spread of fire. But what's kind of curious is the standard says that transportable vehicles are exempted from the standard. So being a tiny house, it's technically a transportable vehicle. It's registered, it's got a tow bar, it's got wheels, but the intent is never to move it. So, it comes down to that vague area. Does this installation need to comply with 5139 if it is relocatable? A caravan that gets moved regularly is obviously a relocatable. What about a donga that gets shipped from mining site to mining site? Is that relocatable or is it semi-permanent? These are still areas of lack of clarity and will come down to interpretation by regulatory authorities. So just flagging that one, that if you want to be safe, assume that it does need to comply. So here we'd have to put a fire barrier behind that battery system. The red casing is at the bases where the batteries are. Also the white case, that's some expanded battery system as well in there. So that would all need to be protected from a spread of fire. And people store explosives like gas bottles right next to their batteries. You can't stop people, once you've left the site, how they use it. So there you go. That's a little wood store. That's the front door. There you go. So let's have a look at another site now. This one's not so flash. In fact, it's just a little shed on a property which services, it's the power system for the houses in this shed. So this is just a workshop. Really, it's not a habitable room. So you can actually put batteries in a shed that's not deemed to be a habitable room. This is an old system. It's over 10 years old. So it was installed long before the battery standard came into place, but it would still, for location reasons, be compliant because it is in a storeroom and a slash shed. What you're looking at there, by the way, is the existing battery system, which has kind of almost reached end of life, as a 24-volt 1,000 amp hour sealed lead acid battery system. When it was new, probably had a usable capacity of about 12 kilowatt hours. Probably after, about 12 years of use, they would have lost a lot of capacity. They're probably down to about, 2/3 of that or so. So let's say they've got about 8 kilowatt hours usable. On the ground next to them, on the right-hand side, are some new lithium iron phosphate batteries. Now, these are Discover batteries, the AES 24 volt. Each one of those is 2.8 kilowatt hours usable, so that's roughly 5.6. So those two sitting on the floor there actually have a similar usable capacity to the old lead acid to the left. And because they a self-managed battery, those AES Discover batteries, they can be used as a lead acid replacement. You can just literally connect them into the DC isolator. But there is a big but here. As soon as you do that, this system would need to be brought up to current standards. So the things that are going to be changed, notably, would be that HRC fuse switch on the wall. HRC fuse switches have been very popular as battery isolators for a long time, but they're not rated to, generally they're only IP20, and the minimum now for a DC disconnect and isolation point for a battery is IP23. So they don't meet the IP23 requirements. So it's time to move up to isolation equipment, and I'll show you some in a minute, that is at least IP23 indoors and IP56 if it's outdoors. It's interesting how people use your battery boxes too. It becomes storerooms. Not unusual to see, explosives, petrol cans, paint, etc., all stored on top of it. That system's got quite a lot of ventilation for a sealed battery, by the way. Generally, sealed batteries don't require quite so much ventilation. And that's a close-up of the Discover AES. Now, this is even a more humble system. This is in basically an animal shelter. This is called a loose box where horses hang out and goats and sheep, and a rather naughty wombat. We've got a rather naughty wombat who's decided that this is the place to be every night and has desperately trying to dig in there. So you'll see we've tried to fortify this shed, which actually has a solar system on it as well. And I'm struggling to open the door for a few minutes here. Sorry, I've got the camera in one hand and I've only got one hand free, and I was really struggling to get this door open. So is an outbuilding such as an animal shed a suitable location for a battery system? Well, it can be. It's not deemed to be a habitable room for humans, though it may well be for animals. So somehow that's kind of an exemption. So it's not a habitable room, therefore you can install a battery system in an animal shed. Look at the hole the wombat's dug under the door. I had to put, an old fence down there, an old gate to try and stop him getting in. I think he's after the animal feed. That's probably why he's digging his way in there. And there is a rather sad-looking installation here. I should point out these are not my systems. These are just some systems that were here, but it's working very well. So it's really it should be better protected from the environments, from dust, etc. And that's the electricals are all in that enclosure there, the inverter and charge controllers. And there's the wombat trying to get in another way through the floor. Fortunately, the batteries are on a concrete slab, so he's not going to dig through that. There we go. That's the little tiny house that you just saw there, sorry. And just giving a bit of a pan around the cluster to give you an idea of the layout here. There's about 7 houses in this cluster, and they're all connected to the microgrid. This one here is connected as a load only. That means it doesn't export power to the microgrid. It only uses it as a backup source. Now, this house is currently empty, so quite all right for me to wander around a bit. No one's in there. This system also is about 10 years old and is a similar one to the last one. It's sealed lead acid 24-volt system with a Laytronics inverter and some Outback charge controllers. Now, you'll note that when we get a bit closer, you'll see this better. The battery box is that big blue box, is located away from the wall. Now, if it's more than 300 millimeters away from the wall, you're not required to have a barrier for the protection against the spread of fire. So actually, that's kind of accidental. That wasn't the intent here when it was installed, but if it's more than 300 mils from that wall, it's not considered to be close enough to cause fire to penetrate that wall. The area of some concern might be that there's a window there, which is an opening window, and it ventilates to a kitchen, which is a habitable room. So probably non-compliant, but it is kind of one of those grey areas if that battery system is 300 mils or so away. And this is the last one to look at. This is in the lab here. This is a system which actually I filmed for today. I did some thumbnails for it, but we just installed this one as a training system. I should point out that this battery you're looking at here is the new LG Chem 13.1 kilowatt hour 48, or it's actually 50 something volt nominal battery, lithium battery. So these are nickel, manganese, cobalt, lithium ions, really high density, like 13.1 kilowatt hours in something the size of a suitcase that you might take overseas with you. Though don't try and stuff one of these into it because it weighs 100 kilos. So they're pretty heavy but very compact. The connections are made here by the AC and DC, and there's a data cable, which is the pink one, which this type of battery is known as a managed battery in the sense that it needs a communication with its charging source to operate safely. In fact, if you don't connect that communication cable within 10 minutes, it self-trips and turns itself off. So that's one of the first things you find when you haven't installed one of these for the first time is if you don't put the comms on there correctly, it'll turn itself off. Now, there is an internal 150 amp circuit breaker in this battery, but because you need an Allen key to get to it, it can't be used as the main battery isolator. So right next to it, we've put in what are the CBI battery isolators in an IP65 enclosure. Now, this is in a shed, training room, a lab. It's not associated with a habitable building. It's basically a commercial location. So there's no restrictions on location here. And also the material of the wall doesn't have to be fire rated. So that form ply is perfectly okay for that battery system. It's within 2 meters. The isolation needs to be within 2 meters of the battery system. And if the inverter is more than 2 meters away from the battery system, you need an isolator at the inverter as well, or the PCE. In this case, it is within that 2 meter cable run, so it's okay. So it's 2 meters in line of sight at both ends of that cable. You need to have a point of isolation. So that's my little walk and talk tour. And I might just pop out of that. So, just going to see if I got some questions. Great. So I'm just checking the Facebook feed at the moment here. Craig says, will you be bringing these existing systems up to the new standards or leave as is? Well, my philosophy, and which is actually the law here, is that if you modify an existing system, you do need to bring it up to current standards. So the definition of modification is where you change anything, including topology, power, voltage, current, pretty much anything. You would need to bring it up to the current standards. So yeah, Craig, they certainly will be. Jamie asks, how different is 5139 to 3011? I understand they apply to different battery types. So Jamie must be familiar with our predecessor to 5139. There were a suite of Australian standards. There weren't joint standards with New Zealand, though New Zealand utilised them. There was AS 4086, AS 3011, AS 2676, and they've been written really for lead acid batteries. AS 4086 was what applied specifically to most installations, particularly domestic installations of battery systems, and it's been superseded and therefore deprecated by 5139. So 4086 is no more, but 3011 still is around because it's for more the commercial application of installation of battery systems. So yep, it's still applicable and can be read in parallel with 5139. To be frank, 3011 was really written for lead acid batteries. So, you know, there will be some points where it won't make perfect sense compared to 5139, which has got a wider scope for chemistries. In fact, the intent was to write it as a hazard assessment process as opposed to, you know, what sort of chemistry you're using. And therefore, any chemistry going forward could be assessed using 5139. Okay, so just realised I closed off a couple of tabs because I was getting a bit of feedback there. So let's have a look over in YouTube land, see if I've got any comments there. Here we go. Sorry, it just takes me a moment to open that screen. And no comments there. Okay, so I'll just stick with Facebook. So we're going to go and look at some drawings now, and I'll sort of explain the standard. Now, I've tried to make this kind of high-level explanation. We're not going to dive deep into every clause of the standard. If you are someone who installs battery systems for a living, you really are required to comply to the standard, and therefore it's a very good idea to purchase a copy. I can't share copies of this because it's copyright. This is AS/NZS 5139. It's quite a substantial standard, and you can see I've got a lot of tags through it just to remind myself the bits I need to look at all the time. So get yourself a copy of this from Standards Australia or Standards New Zealand if you're in New Zealand, and it's a bonus if you're in New Zealand. Don't have to pay for it if you're a member of the Electrical Workers Board, I think it is, or registered with the Electrical Workers Registration Board. So let's have a look at a high-level overview of the standard. So I'm just going to make sure I've got everything in the right place here. There we go. So let me give some very broad strokes about this standard. It's written so you can choose the relevant section to apply depending on what type of battery system you're installing. So you don't have to read all of it. And really the three main sections that will have an impact and that you need to choose, which is appropriate, are sections 4, 5 and 6. Now these three sections refer to three different categories, and the number of sort of risk factors associated with them increases as you go from left to right. So if we start off on the left-hand side, let me define my terms. A BESS is an acronym for Battery Energy Storage System. And so the blue line here refers to something that is a pre-assembled, see down here I said pre-assembled, compliant to the best practice guide, and I'll explain that in a minute. It has a battery, or batteries, or battery modules, and it has power conditioning equipment. You could think of that as an inverter, typically. And it is one complete system. So thinking what you saw in the video at the beginning of today's Toolbox Tech Talk, there were two BESSes shown. One was the Alpha ESS Smile 5, because that's a pre-assembled BESS, and the other was the eStore. That was a pre-assembled BESS. Now this bit here is where it gets a bit complicated. It also, because 5139 was pretty heavily focused on lithium-ion batteries, BESSes under Section 4 only apply to lithium-ion batteries which are part of a pre-assembled system compliant to the best practice guide. Now, what on earth is the best practice guide? Let me just bring that up to give you a quick look at it. The best practice guide is free. You can download it from, just thinking what the address is, batterysafetyguide.com.au. So batterysafetyguide.com.au is where you can download this from. Now, this is actually written for manufacturers of product. It's not an installation guide. It's a kind of a quasi product standard. When I say we, a group of organisations, including the AI Group, CISA, Clean Energy Council, CSIRO, and the Smart Energy Council, co-authored this. It was also heavily contributed by the Queensland Electrical Safety Regulator, the Office of Electrical Safety in Queensland, who kind of wrote the first best practice guide for Queensland that this was then based upon. So this is really a way of asserting whether a lithium-ion battery system is of a high level of safety. And there's 4 methodologies within this best practice guide that a manufacturer can deem compliance to. So it's a self-declaration. They basically make sure that they can tick all the boxes on each one of those 4 methods and issue a confirmation of compliance to that. It isn't a test standard. You don't say, oh, I've been tested to the best practice guide battery storage equipment. You just have to state that you are compliant to it. But the Clean Energy Council do maintain a list of companies who have made that declaration, so you can see what battery systems and BESSes are compliant to the best practice guide. And like I said, it gives a bit of an advantage because there's less onerous clauses associated with something in Section 4. So Section 4 in a way is the lightest on for installation requirements in terms of extra things that you might have to do for all sorts of different hazard levels. Section 5 is just the battery system associated with some other power conditioning equipment. So this inverter may be from any other manufacturer. So this is not part of the battery system. It's a secondary component. An example of that would be, you saw at the end of the video I just showed you, a LG Chem with a Selectronic SP Pro. The LG Chem is a lithium-ion battery compliant to the best practice guide. It is a battery system, therefore, and it just happens to be connected to power conditioning equipment, in this case, a Selectronic SP Pro. So it sits under Section 5, which has a few more clauses, particularly because you're now installing DC cables. In this case, with a BESS, everything's pre-assembled. Now, pre-assembled's kind of a bit misleading. Doesn't mean it was actually all built in a factory and shipped to you as one piece. You may have some on-site assembly of that pre-assembled system, but there's no on-site manufacture. So you don't make up any cables, any lugs, choose any overcurrent protection devices. In Section 4 systems, all of that's been done for you. You're basically just doing an IKEA where you just follow the instructions and put it all together. Whereas here, the battery system is pre-assembled, but you are now selecting cables, overcurrent protection devices, possibly monitoring as well, associated with the PCE, the power conditioning equipment. So therefore, it's a Section 5. Section 6 is where it gets tough. Section 6 can be for a BESS a battery system or some other concoction that isn't compliant to the best practice guide. See? So if it doesn't comply, non-compliance to the BPG, best practice guide for short, if it doesn't comply with the best practice guide, even if it's a lithium-ion battery, it ends up in section 6. Doesn't mean it's unsafe. It just means we don't know. There isn't a product standard that we can refer to. So ironically, some of the safest systems end up in section 6. You might actually have a battery that has no explosive gases, no thermal runaway, no hazardous chemicals, but it can't fall into sections 4 or 5 because that's only for lithium-ion batteries. Now, this is really the growing pains of this standard and growing pains of the fact that we don't have product standards for energy storage devices in Australia. And if we did, we could probably drop them into these lower risk categories because we could say, well, if you met this product standard for this type of battery, then it's deemed to be safe. We do have product standards, ironically, for things like hoverboards, electric vehicles. Therefore, they're exempt from the standard. Of course, a hoverboard is, and electric vehicles exempt, even though it's parked in your garage right next to your BESS, because it is compliant to a product standard and therefore exempted from 5139. So there's a rough overview of those sections. What I want to do next is really just start to look at locations and some of the more sort of curly issues that you might have to consider. So, as I mentioned earlier on, a fire barrier is required if there is a habitable room behind. So in this picture here, here's a house. It's made of weatherboard, so it's not a fire-rated material. There's a battery system on the corner of the house, and the exclusion zone for equipment and the size of the fire barrier, which is the same dimensions, is 600 mils horizontally and 900 millimeters above. So because it's on a corner, that 600 millimeters logically wraps around the corner. So there's one example where it's not just on a smooth facade of a wall. Now I'm just checking to see if I've got any more questions come in. So for those who are not familiar with my Toolbox Tech Talks, you're welcome to ask questions in the chat window. I'm actually not that great at monitoring all the different platforms at the same time, so I'm actually mostly looking at the Smart Energy Lab Facebook page for questions. I did jump over and have a quick look at the YouTube channel to see what was going on there, but I started getting some feedback, unfortunately, so I had to jump back out of that. So I'm just going to have another quick look at YouTube, see if we've got any questions. And fortunately, so I had to jump back out of that. So I'm just going to have another quick look at YouTube, see if we've got any questions. And fortunately, so okay, so I did see a question on YouTube there. Sorry if you got a little bit of feedback while I was looking. So someone asked, so is Section 6 also for lithium-ion batteries? Yes, it is, if they're not compliant to the best practice guide. So, you know, if the manufacturer hasn't gone down the path of deeming compliance to the best practice guide, even if they might be able to do it, they just haven't done it. Therefore, they become a Section 6. So sometimes it's they're new to the market in Australia or New Zealand, and they haven't really gone down the path of ensuring that self-declaration has been done. All right, so that's a house where there is a battery system on the corner of a house with a combustible surface. Let's have a look at another one here. So this is where we've got a bedroom behind, and once again, it's a weatherboard house. The fire barrier extends 600 mils horizontally, 900 mils above. And by the way, if the eave is less than 900, then the eave needs to be lined as well. So that's the other complexity, that the eave, if it's less than 900, the fire barrier extends up to the eave and out to 600 mils beyond the front face of the battery system or BESS. So that barrier then could typically be like cement sheeting or one of the materials listed in 5139, which Most people would choose cement sheeting because it's relatively easy to attach. But if you wanted to put up a terracotta barrier, a brick barrier, a material rated to AS 1530.1, which is a non-combustibility test, then you could do that instead of having this cement sheet barrier behind the unit. And let's go one more. I think this is the last one I've got drawing. So here we go. This is a combination of considerations, and here we've got a doorway. Now it says that you need to be 600 mils from any exit, so a doorway is an exit. One of the curly ones that comes up sometimes is a garage door an exit? A garage door can be like 2 meters wide, heaps of room to get around and out, but it is a point. It may well be deemed an exit, and therefore you've got to be with more than 600 mils away from that exit. There's a window here, but only the right-hand pane is the moving part. The left-hand pane may be fixed, so it's from the moving part of the pane that you need to be more than 600 mils away. It's about ventilating into a habitable space. So that's the issue there. And if this is a brick wall, so this is brick, we don't actually need a fire barrier. Because it's a brick wall, we just have to maintain those clearances from windows and doorways. So a brick wall kind of makes it a little bit easier. Now, I'm just checking for comments here. What are non-habitable rooms in a house? Hallway, kitchen, laundry, storage, toilet. I thought of bathrooms were. Now, this is the wording in 5139 describes habitable rooms, but only gives you an indicative list. A better guide is the National Construction Code for Australia. I'm not sure what the New Zealand equivalent is, which actually lists habitable rooms. The CEC have produced quite a useful document called Advice on Compliance to 5139, where they've shown a whole bunch of different habitable rooms. Because it's their content, I don't want to bring it into my live. It's if you're an accredited installer, you probably can just download it from your login page. But yeah, that's quite a useful list. But if you have access to the National Construction Code, which for the last 5 years or so has been free, which is great, you can actually see what the list of habitable and non-habitable rooms are. I see Brian asks, NECA offer AS5139 if you're a member. Go NECA. That's great. Really good to see. So they must have a group license for all their members. So yeah, excellent. It's good to see industry organisations helping you out with keeping the cost down, because buying standards can be really rack up when you start to think about all the ones that you need. Just in the renewable space, it's typically 5139 for batteries, 5033 for PV arrays, 4777 for inverter systems, 4509 if you're doing off-grid systems or standalone systems, 3010 if you're doing generating sets associated with those systems, and that's just a start. So there goes, probably close to $500 to $1,000 worth of standards. So yeah, that's great to hear that NECA are helping out. So that's kind of what I wanted to cover today. Just bring myself back on, is just talk a bit about location considerations. Now, if you're not an installer and you're watching this and you want to work out where you can put a battery storage system on your home, you really need to talk to an installer who understands this standard. It's not something you can do from looking at satellite imagery of your house and say, yeah, we can put a 6 kilowatt system on your roof, no troubles, because we can see the roof. That's not good enough. When it comes to installing a battery system, it's much more specific about where the windows are, where the doors are, where the habitable rooms are. So you'd be wanting someone who's prepared to come and visit your home and check those things out. So batteries really have raised the bar in terms of site visits being more or less the only way you can install a battery system with any confidence, because if companies are selling battery systems without doing a pre-flight check, basically going to site and checking it out, they could be coming back home with the system because they can't install it. There's just nowhere. So yeah, it's pretty tough, this standard. It has raised the bar for safety. Some would say too far. I know it's very contentious in New Zealand at the moment because they were the major objectors to the standard. There was quite a lot of votes against this standard from the New Zealand members of the committee, but because it bases on a certain percentage that needs to be achieved, a bit like the US elections, they didn't succeed in stopping that standard being published. So yeah, it is a little bit contentious, and like several of our other standards, 5033 for example, we really are, you could say, leading the world in terms of some of the toughest regulations around safety for battery systems. So there you go. So I'm just going to wrap it today a little bit earlier than usual. Thanks for those who attended and all your questions. That's great. I'll be back same time next week. Now, I do plan to bring some guests in, hopefully next week. So it might be a different format with a guest that I'll be interviewing. So I hope to see you back 2 o'clock Melbourne time, Sunday next week for another Toolbox Tech Talk. Okay. Thanks, everyone.